Enhanced QR code security. Since the day smart devices and internet are invented, things have become more convenient as almost everything could be done using smart devices with access to the internet. The advancement of technology never stops. With the appearance of QR code, our lifestyle has changed and benefited from it gradually. So, what is QR code? QR code was invented in 1994 by a Japan company, Tensor Wave Corporation. It is a two-dimensional square matrix format barcode where it could encode the information like numbers, letters, and candy characters. It could store the information in two directions, which is horizontal and vertical direction, which mean it could store more information up to 406 bytes than a normal barcode within a limited space. The structure of a QR code consists of an encoding region, cell, and a functional pattern. Functional patterns are such as finder patterns, alignment patterns, timing patterns and quiet zone, which makes the reading of the data easier and provides an area for data storage. Besides, the finder patterns are located at three corners with intention to ease the location and identification of its position, size and inclination. Moreover, the alignment pattern acts as a correction pattern that will correct the distorted QR code, while with the black and white patterns, it allows the timing pattern to better identify and correct the central coordinate of the data cell at the time the QR code symbol is distorted. Furthermore, the quiet zone is a margin space needed for the reading of the QR code, while the data will be stored in the data area in the symbol. Currently, there are 40 versions of QR code and 4 levels of error correction L, M, Q, H, from 7%, 15%, 25% to 30%. Nowadays, a lot of different threats or attacks exist with an intention to take advantages from the others through security breaches. This could result in various actions such as a phone number being automatically dialed, a short text message being sent, or the worst where a phone being wiped or vulnerabilities in the reader software being triggered. One of the threats is grishing. This is an attack method that used in the QR code where the attacker will create a QR code with a fake and replica website that's similar to the original website and stored inside QR code. When the user scans the QR code, the user will be directed to a phishing website and the personal important data will be sent to the attacker if user enter his credential information. Grishing can be put through an advertisement poster because we human cannot determine the QR code's content by looking at the code. The attacker will simply cover the original QR code with the fake QR code that with the same dimensions in the poster. There is other way to carrying out this attack through other mediums such as email, business card, banner or even an online fake advertisement. Moreover, another type of attack is the malware attack. This attack is similar to the phishing attack. The same concept will be implemented, and when users scan the malicious QR code, the user will be directed to the fraudulent URL. This URL link will contain the malware that forcing the user to download the malicious application. The malware such as spyware will be installed in the victim's phone and collects the personal information of victim without their knowledge. In this research, 2 existing solutions that are proposed to enhance the QR code security will be studied and analyzed, which is QR image and embedding a digital signature into the QR code. The first solution would be embedding QR code into an image. This method is used to hiding the information of QR code into the color images, which means combine the color image and the QR code with any color image can be embedded into the QR code. This method could be accomplished with 2 types of technique. The first technique used is half-toning technique. This technique is used to select the modified pixels to eliminate the coarse square structure of the QR code and create the mask of color image. The second technique is luminance modification, where it is used to optimize the luminance level of the QR image in order to minimize the image distortion. The first step of the embedding process is first choose the input material, which is the QR code and the color image. Then, the image will be masking to be used for image ordering and split into the block of modules. After applying the half-tone technique, the mask of the color image and the half-tone mask is generated to further combine to be the QR image. QR code with digital signature. The security of QR code is improved in such a way that the QR code is modified and can only be authenticated using a built-in security feature. Firstly, the message is hashed by using a hash function to produce a hash value, or message digest. Then, the private key held by the sender and the hash value will be combined to produce a modified secure QR code. Then, a byte string will be obtained when the secure QR code is scanned by the designed application. By generating two copies of the byte strings, the digital signature is extracted by comparing the corrupted byte string, corrupted due to insertion of digital signature, to the recovered byte string, recovered by using the Reed-Solomon error correction method. After that, the receiver could obtain the hash value, A, stored in the digital signature by using the public key. By hashing the message interpreted from the recovered byte string, the hash value, B, could be obtained. By comparing hash value, A and B, the receiver is then able to determine whether the message is sent from verified sender or whether it had been altered in transit. To better enhance the security, a solution is proposed. The proposed solution will be adding another layer of security on top of the digital signature to secure the information carried by the QR code. In short, an additional cloud storage is implemented by using the concept of Globally Unique Identifier, GUID, to store the information. With this, even if the attacker by any chance obtain the public key to decode the digital signature and gets the information stored, what the attacker will get is only their GUID. The attacker would need to go through another layer of security, which is the cloud database, to get the data bind with the GUID. This has hugely improved the QR code security in message sharing. The overall process of the proposed solution will be described as follows. First, the process will start with the user who make a request to a QR code generator application to encode the message to a QR code. The message can be anything depend on the purpose of the application, such as food ordering content, website URL, information to connect Wi-Fi network, information to advertise a product, and so on. The application will then process the request and send it to a cloud server. When the cloud server received a request, it will trigger their GUID, generate a unique GUID for the message. After that, the server will bind the GUID with the message and store it in the cloud storage, which could be retrieved in the future. Then, the GUID will be encoded into a QR code with the implementation of digital signature. So, when another user tries to access the message, the QR code will be scanned using the QR code decoder of a designed application. If the digital signature is successfully validated, the QR code will be decoded and the content of the QR code will be further analyzed by the content analyzer. The content analyzer will determine whether the content of the QR code is a GUID. This is important because there will be the possibility that an attacker could obtain the private key somehow and create a fake QR code with malicious content using the private key, in which it is able to bypass the authentication layer of digital signature. The fake QR code will then lead the user who scanned the QR code to a malicious website or even implant a virus into user's device. Content Analyzer can avoid this type of threat effectively, as it denies any content of the QR code beside GUID. Lastly, after the content of QR code has been analyzed by the Content Analyzer and assured to be a valid GUID, the message will be retrieved from cloud storage according to their GUID. The figure shows the overall schematic diagram of the proposed solution in detail. In conclusion, in this paper, an overview regarding the structure of QR code and threat towards QR code had been provided. A few existing solutions also had been analyzed to provide a better understanding of pros and cons of the existing solution. Lastly, a solution which consists of two layers of security, digital signature authentication and GUID with cloud storage, is proposed to enhance existing solution to prevent possible threats more effectively. Thanks for watching the video. To better